Hello, math friends. Today is going to be kind of the third installment of a little trilogy here. Lessons 2, 3, and 4, I had said go kind of together as we dive into dealing with angles in standard position and trying to figure out what we know from those angles in standard position. So, very quickly, I'm going to take you back to lesson 1. The back half of lesson 1, we introduced the concept of angles in standard position. Then we went into special triangles and we said, hey, how about we put special triangles on different spots in different quadrants and grab sine, cosine, and tangent ratios from those special triangles. Then yesterday, we said, okay, let's forget about special triangles, but let's do the same thing we were doing with the special triangles and use values for x and y instead, okay? So now what we want to do is just kind of wrap this up. This actually isn't a long unit or a long lesson today, but we want to wrap it up and really focus on solving for the angle now instead of the ratio, okay? So if I ask you for sine theta, I'm looking for the ratio. I'm looking for some sort of ratio from a right triangle that involves y over r or opposite over hypotenuse, however you want to look at that, okay? If I ask you for theta, now I'm looking for an angle, okay? Sine theta asks you for a ratio. Theta asks you for an angle. And usually to get theta, you're going to have to find a ratio, and then you're going to have to arc sine or arc tan or inverse sine or inverse tan, second function sine, okay? All right, so let's take a look and see what we can figure out. The first question here is solve for theta if sine of theta is 0.5 and theta is between 0 and 360 degrees. Now, the first thing I want to talk about, and I'm going to hide myself for just a second. First thing I want to talk about is this up here. I'm going to have this on every question. This is called the cast rule. Different teachers call it different things. But what it is just a quick reference as to who is positive in which quadrant, okay? So in quadrant 1, I have an A. A stands for all, okay? All ratios are positive in quadrant 1. In quadrant 2, though, only sine is positive, okay? That means cos and tan are negative. In quadrant 3, only tan is negative. And the reason tan is, positive. The reason tan is positive is because you have a negative x value and a negative y value. And when you divide both of those together, you would get a positive. And then in the 4th quadrant, only cosine is positive, okay? Only cosine. So the cast rule quickly tells us who's positive in what quadrant. Some teachers teach the cast rule as all students take calculus, which, by the way, if you haven't registered for calculus, calculus is a great thing to register for. You should talk to your guidance counselor and make sure you're taking calculus in grade 12. Okay, so why do I have the cast rule there? And why am I going to have the cast rule there all the time? Well, what you need to understand here is if I'm going from 0 to 360, there's always 2 different answers that will produce the same ratio, okay? So what we actually need to do is kind of 2 things. We need to think about, okay, what is the reference angle that will produce this ratio? And to do that, we can arc sine, or we can set up a special triangle if we think it might involve special triangles, okay? Either one would be okay there. And then once we have the reference angle, we need to figure out what 2 quadrants sine is positive in. Well, according to the cast rule that we were just talking about, we know that the sine ratios will be positive in quadrant 1 and in quadrant 2, okay? So I know that my reference angle can be applied to quadrant 1 and quadrant 2, okay? So the first thing I've done here is I've said sine of the reference angle equals 0.5. So the reference angle will be the arc sine of 0.5. The reference angle is 30. I want you to take note, in my communication here, I have talked about the fact that I'm getting the reference angle, not the actual angle, okay? That's really important. That's why I've stuck this little R here as a subscript, okay? It's the reference angle that we're dealing with right now. Now I need to apply my knowledge of what 2 quadrants I'm in and apply that reference angle to the 2 quadrants, okay? So I say sine is positive in quadrant 1 and quadrant 2. So my first value for theta will be 30. That's the one from quadrant 1. My second value for theta will be 180 minus 30 if the reference angle of 30 is in the second quadrant. Okay, so I have two answers, 30 degrees and 150 degrees. This is the sort of work I need to see for every question, okay? I need you entertaining with me what the reference angle is, then what two quadrants I should be in, and then what my actual answers are based on that reference angle in those quadrants, okay? All right, great. Let's try this again. Okay, solve for theta. This time sine of theta equals -1 over root 2. Now you may look at that and say 1 over root 2, that's root 2 over 2. That's on a special triangle somewhere. Fantastic. If you want to build that special triangle right now and figure out what the reference angle is based on your special triangle, go for it. Okay, if you want to arc sine this or inverse sine this to figure out your reference angle, go for it. Okay, I just need those three things interacted with. I need how you got the reference angle, how you know what quadrants you're in, and then what your answers will be based on your reference angle and the quadrant. Okay, so I am going to arc sine 1 over root 2. Now I want you to notice I ignored the 1/2. This is where the whole reference angle versus real angle becomes very important. Your reference angle is always acute. It's always less than 90 degrees. So if I want the reference angle, I am never going to arc sine the negative portion of my ratio. The negative portion of my ratio comes to tell me what quadrant I'm in, okay? But for the reference angle itself, you will always arc sine or arc cos or arc tan, the positive version of that ratio, okay? So I have sine of the reference angle is 1 over root 2. And now I'll arc sine that. And that gets me a reference angle of 45 degrees. Okay, so now I'm thinking, okay, what two quadrants is sine negative in? Well, this time it'll actually be quadrants 3 and quadrants 4. Okay, so I'm going to apply my reference, and I know it's, sorry, just for clarification, I know it's negative because the ratio is negative. Okay, I want to make sure I'm not going too fast here. Okay, so I know I'm in quadrants 3 and 4 because those are the only two quadrants where sine is negative. Okay, if I'm allowed to go from 0 to 360, there will always be two answers. For everything you are given, there'll be two answers, okay? With the exception of a couple quadrantal angles. Okay, so sine is negative in quadrant 3 and quadrant 4. Those of you who don't like to write stuff down, I need that statement. This is how you're communicating to me how you're going to apply the reference angle, okay? Okay, so theta 1 will be 180 plus 45. That's the reference angle right here, right? If I had a reference angle right here, I would go 180 and I would add my reference angle, and that would give me the angle in standard position. The next guy will be 360 minus the reference angle. Okay, 360 minus the reference angle. And so those two guys, my final answer will be theta is 225 degrees and 315 degrees. And it's good to write those in set notation brackets, okay? Because you're defining a group of values. Okay, great. You got this. Okay, solve for theta. If cos of theta is negative 0.6753. Now, for sure, there's no special triangle here. You're going to have to arc cos it and get the reference angle. Again, though, you're going to arc cos the positive version so that we can get the reference angle. So we're going to say cos's reference angle is 0.6753. Notice I have dropped the negative because I'm dealing with the reference angle only. Okay, so then I'm going to arc cos that, and I get a reference angle of 47.5 degrees. Now, I know that cos is negative. Well, if I go back to the cast rule, I haven't actually shown you that picture for a little while. I'm pretty sure I'm cutting off some of the top letters. So I will just show you that picture one more time. I'm hoping you're writing it on all of your questions here. Okay, so if I'm looking for when cos is negative, that will be in quadrant 2 and in quadrant 4, because cos is positive in quadrant 1. Sorry, quadrant 2 and quadrant 3, because cos is positive in quadrant 1 and 4. Okay, so I'll be negative in quadrant 2 and quadrant 3. Okay, So cos is negative in quadrant 2 and quadrant 3. In quadrant 2, I end up going 180 minus my reference angle to get the angle in standard position. And then in quadrant 3, I will end up going 180 plus my reference angle to get my angle in standard position. So my two answers are 132.5 degrees and 227.5 degrees. Okay. Good. You can do this, guys. Okay, solve 2 cos theta equals 1. Okay, same thing we've been doing. There's just a slight more algebra to do because I don't have cos theta by itself. I have 2 times cos theta. Well, just divide by 2, right? So that's cos theta equals a half. Now, if cos theta equals a half, I'm going to arc cos a half to get the reference angle. And that's going to give me 60 degrees. I want to think, okay, where is cos positive? Cos is positive in quadrant 1 and quadrant 4, according to the CAST rule, right? You can write that on every question. Quadrant 1 and quadrant 4, so that means my answer will be 60 for the quadrant 1, and then it'll be 300 minus 60 for the quadrant 4. So I end up with 60 degrees and 300 degrees as answers. Don't forget to be putting those degree symbols anytime you write a degree answer. That is very, very important, okay? All right, and let's try this guy. Again, just a little bit of algebra involved, but not much. I need sine theta by itself. So I'm going to subtract root 3 from both sides, and then I'm going to divide by 2. So that's going to give me sine theta equals negative, because I had to subtract root 3, right? Negative root 3 over 2. And then I'm going to arc sine that, but I'm going to ignore the negative because I need the reference angle. You may recognize this as a special triangle if you want to build your special triangle and figure it out that way. Awesome possum. You will have to build special triangles. So if you want to do it here as well, perfect. Okay, so the reference angle when I arc sine positive root 3 over 2 becomes 60 degrees. And then I have to think, okay, my sine ratio is negative. When is my sine ratio negative? Well, that is between quadrants 3 and 4, the bottom 2 quadrants. So if I apply my reference angle to quadrant 3, that's going to be 180 plus my reference angle. And if I apply it to quadrant 4, that will be 360 minus my reference angle. Okay, so my two answers there are 240 and 300. Okay, 240 degrees and 300. All right, fantastic. Okay, that's it today. That's what you're practicing as we kind of wrap up this whole conversation around angles and standard position. The next 2 lessons are going to do something very new to you. You haven't dealt with it at all. It's called the cosine law and the sine law, where we'll actually be able to solve for unknown lengths without it being a right triangle. So stay tuned for that. That'll be very exciting. But for now, I've posted your homework here. For those of you who are my kids at school, make sure you get this done and make sure you're coming in to see me with any questions. And all of you, make sure you're practicing, okay? Make sure you're giving yourself the time to feel good about this stuff and connect with me if you have any questions, okay? Thanks, guys. Have a great day.